Hey guys, my name is Tomasz Rywak and today I want to show you my latest project. The name of this project is Image Inspector and it's a very simple website, though even though it's a website, it actually works purely on the client side within the browser, so it doesn't have any backend or anything like this, but it's a website that you can use to upload an image and then apply different filters on this image and see the output. So in this case, our base image looks like this. This is something that I drew some time back, and will not focus on what that thing actually is. Though on the right you can see that we have this base image and we can also have two filters. Those filters are actually here by default when you load the website, and we have a vertical line detector and the horizontal line detector. If we click on the vertical line detector, we will see that it will highlight all of the vertical lines, and the horizontal line detector will highlight all of the horizontal lines. We can also load a little bit simpler example. So this is something that I have drawn in Paint. And so this is this image. And then if we click on the vertical line detector, it only highlights vertical lines, and the horizontal line detector only highlights horizontal line. In this image, some lines are like under an angle, so both of those filters will actually highlight those lines. And also, so this is one feature of this software. Also, if we hover over the image, we will see the values of those filters on the right. So here, we can see on the top the values of different channels of this base image. So RGB, red, green, and blue. So if we hover over this head here, we can see that we have the highest value is for the last channel, which is for blue. And also we can see those values, what values are being calculated as the specific position for our horizontal and vertical line detectors. Of course, this is not only limited to those two filters, those are just two examples that are here by default, but what is most important is that we can actually modify them. So let's click here and change this, let's take a look at the code of this vertical line detector, and a short note here. So for those code editors, I'm using a library that is called Ace Editor, if I remember correctly, and it's a very nice library, so I have used it also in the past with my different projects, and I can definitely recommend it. So you simply get some very simple to use component which you include into your website, and you get this beautiful and easy to work with code editors, and then you can simply fetch the current text within this editor after the user is done editing it. So as you can see, we have a vertex shader and we have a fragment shader. And if you are familiar with WebGL or OpenGL, then you will know what those shaders are. And if you are not familiar with those, you can always just then take a look at this calculate value function, which is like the core of the whole solution. So it takes the x and y coordinates of the image and tries to calculate the output color of this filter. So if you want to simply if you want to create just a simple filter, you can just go here and modify this body of the function. And if you know what you are doing, then you can modify both of those filters entirely. So even though we have those indicators, the comments at the beginning, they don't have any special meanings. I just wanted to highlight that this is the main part that you can modify and interact with. But if you feel like that, you can modify everything here. But the main purpose of the vertex shader here is to calculate the coordinates of the texture that are being used here. And here we can use a helper function that is defined here, which simply returns us a color at a specific position. So when it comes to the vertical line detector, it works in a way that we take a color of a pixel to the left and the color of a pixel one to the right. And with those two samples, well, we calculate then the difference of the brightness of those two samples. We take the absolute value and then return the calculated filter. Here we set the R, G and B channels, so red, green and blue channels to the value of this filter. And the last channel is the alpha channel. So transparency, we set it to 1 because we want to be like fully visible. And then we can compile it. Here we can see that it was compiled successfully, but if we would make any change here, we would see all of the errors at the bottom. So we can follow up based on those errors and try to fix this. And if we would save it or change it, we would see all of the changes there. But for now, let's cancel it. And we are not only limited to those two filters, we can add more filters. So let's add something custom. And when we add something custom, we end up with those bare bones vertex and fragment filters, shaders, sorry. So everything that we would need is already defined, and all we have to do is actually implement the body of the calculate value method or function, however you want to call it. So let's put our code here. I will for this just cancel this thing, and I will copy the body of the function from another filter. I will pass it here, and what I want to create is a filter that at the same time will detect all of the horizontal and the vertical lines and will highlight them in a different color. So let's do it so that we will take those samples not only from the up and down, but also from the left and right of the current pixel. Let's call those samples differently, and let's calculate two separate differences. So the difference for the vertical lines and the difference for the horizontal lines. It's a simple copy paste, so there is no much that can go wrong. And then on the output, let's use one difference for one channel, a second difference for the second channel, and let's set the blue channel to 0 so that all of the fragments that do not contain any of those lines will simply be black. And of course the last alpha channel is set to 1. Let's compile it. We can see that everything is okay, and now of course I can rename this layer my layer, and when I save it, we can see here the outcome of filtering this image with our custom shaders. You can see that here vertical lines are green, horizontal lines are reddish, and lines in between are also colors in between. So those are the mix of those colors from the vertical lines and the horizontal lines. So you can see here that they are somehow orange or something like this. And also if I would hover over those lines here, we can see on the right that this line in this specific position is more red, so it's more horizontal than the vertical, it's vertical, so the horizontalness of this line is 150 and verticalness of this line is just 008. So it's much more horizontal. But we can also see it simply by looking at this. We could also probably see it simply by looking at this image, but yeah, if you would have like a different, more complex filters that are not only based on just the exact surroundings of the pixel you are looking at, because you can always also get the values of the pixels like much further away from the current position. So if you would have like a very complex shader, then you probably would need to actually look at it to examine what is the exact value in a specific position. And I think that this summarizes of the main features of this But let's also take a look at the code. Oh, one more thing, you can also open and save those layers that you define here. So if you want to like reload the page, then I would recommend first to actually save your shaders, and then you can reopen them and like then load another image or something like this, so that your changes are not lost. And as I have mentioned, it's a website, so we can go to this URL and open it. And so it's a website, it's implemented in JavaScript, and I've implemented it using React.js. So React.js is a UI framework, let's call it like this, for web applications. I actually really enjoy it, but you can see that it's relatively simple. So there are like 8 components here. Yeah, so that's not much, and those mostly represent the menu here, those layer summaries here, and the general working area in the center. The one thing at first when I started to implement it is that I thought, well, I wanted to have this so that when you hover over the image, you only see the this circle around your current cursor position with the filter, and the rest of the image would be just the base image. And when you leave the image, it like spreads to cover the entire base image, so that you can see the entire filtered image. At first I thought that I will implement it in a way that I will create a custom shader that will work in real time. So whenever you would move a mouse, it will recalculate what is being rendered, and the user would see this in the output. But then I thought that it's maybe a little bit overcomplicated. Well, it's definitely overcomplicating this, and there is actually a solution for implementing it in just pure HTML and CSS with just a little bit of touch of JavaScript. So it works in a way that there is this preview, and I just use the clip path right now. So there is a clip path of a circle, and it has the position of the current mouse position and the radius of if we are hovering over the image of 50, and otherwise of the distance from here to here, so that it always covers the entire image. Another thing from the implementation perspective that might be interesting is how the editor is implemented. Well, I'm not talking about this text editor, but actually about the compiler. You might think that it's complicated because, yeah, it might be that to create some solution like this, you would have to actually embed some kind of a compiler in your project, but it's not the case when it comes to the WebGL and shaders, because because when you try to load a shader, well, when you try to ship a shader with your solution, you are actually shipping a source code of the shader. You will never ship it as a precompiled binary or anything like this, because GPUs don't accept things like this. They will simply require a source code, so a simple text file or a string that they have to actually that they can interact with. And then based on those source files, they will simply compile it at the runtime and return you the error messages if there are any, or a success indicator if the linking of the program was successful. So the hardest part, the part that might seem as the hardest thing of the project, is actually very simple, because this comes out of the box with the WebGL. So if we would look at the here in the source code at the utilities layer, we render the image. Actually, whenever you actually hit compile, underneath this software actually renders the image to make sure that everything is correct, because otherwise it would get those error messages that it could display. And the part of this process is linking of the program, and here we have we have a shader loading, and we load the shader. So this is actually the built-in function of the WebGL rendering context. This is not something that I've implemented. We compile the shader, and then we simply try to see if there are any compiling errors. And if the compiling wasn't successful, then there is an error which we can display on the output. And that's it. So the compiling here is very simple, and yeah, probably usually it's a little bit annoying because every time you have made some changes to your shaders, you have to actually probably run your program. Probably in some cases you could create some kind of a tool that would check if your shader is correct without compiling it. But yeah, it might also depend that it's also a case that different GPUs have different capabilities, and also the WebGL has different capabilities than the OpenGL in some cases, so it like uses a little bit older standard. So yeah, that's probably why it's designed this way. But yeah, in my case it was actually a blessing, so all I have to do is get the text that was created by a user and then compile it with built-in functions of the geo context, and I get all of the errors that I can display here. So nothing fancy gets place when it comes to the my implementation. Everything is lifted here by the predefined functions of the geo context. Another thing that's might be interesting from the from the implementation perspective is that you cannot actually add more than 1, 2, 3, 4, 5, 6, 7, 8 contexts here, because web browsers, in this case Firefox or Chrome, do not support having more than 16 8 or 16, I think that's 16 geo context. So the drawing context that I use for drawing those images, one way in which you can overcome it is by rendering all of your outputs in a single context on a single canvas, and then displaying only a sub part of those canvases whenever user requests them. But in my case, I've decided to go with a simpler solution, so simply limiting the user on the number of contexts they can actually load in this software. It might be a little bit lazy solution, but yeah, it's just a pet project, so I didn't want to spend too much time on trying to fix that. Yeah, so if you would look at this project, it's very simple. If you want to actually look at the source code of this project, it's available on my GitHub. So yeah, all of this is available here. And if you want to run it, you simply have to actually let's take a look here. You have to run the npx webpack command, and it will look for all of the changes in the source files and compile those the source code and put the output into this dist, so distribution folder, and then you can simply open the index.html to run this website. So you don't need any web server or anything like this. It's a very simple and plain HTML site. Yeah, so I think that's it when it comes to this software. As I've mentioned, it's very simple, so it's probably the simplest project I have presented here so far. Yeah, I would say so, especially compared to the last two projects. So there is no much going on here, but I still wanted to share it because I finished it and I don't want to simply leave it hanging on the GitHub. I wanted to create this video as well so that I can move on to my next project, which will probably also be somehow related to the WebGL. I want to create some kind of a 4D renderer, but I don't know if I will like have enough time and willpower to actually finish it, but fingers crossed. And yeah, I hope you liked it, and see you in the next video.